Hello everyone, my name is Nicoya, and this is the MG-1 again. So when we last left off, we had a little bit of an issue with the pitch slowly rising if we left this in the continuous mode, not the keyed mode. And we also had an issue where tone source 1 was all kinds of out of tune and not tracking the keyboard one-to-one, and it was a little bit evil sounding. So today we are going to go ahead and hopefully fix both problems. Now, I just remembered I put the knobs back on here and I'm going to have to take them off, so let me do that. That one is very stuck. Okay, knobs are off. Let's get the screws out. And there we go. We are back open. So, they're falling off. All right. So as we remember from our last time, if we look at the schematic, we have our keyboard control voltage coming through here. It goes through the keyboard glide potentiometer, which is this one here. And then it goes into C13 and into U7A. And also goes through U7B, where it's mixed with some other tone sources. Now, this was drifting up, and if we plug this in and switch it on, we should be able to see that happen in real time. So I have my meter going, and I actually need to change one of its settings. There we go. We're in the 10 gig ohm range instead of the 10 meg ohm range, and so that means that our voltage is going to be swinging around a lot, but that's fine because it also means that our input impedance is way up, and so we won't be dragging down the voltage on this node here when we're measuring it. So let me see. We'll need to plug this in. And as always, watch out this area. That's where the high voltage is. And we can power this on and grab our leads. So let's see here. So our glide was right over here. And so if we find a ground, which should be here, that should be a sufficient ground, and then check our glide, we are at 2.6 volts and slowly climbing. So that's not great. We can reset that by playing a low note. And we can see that we've reset it, but we are again slowly climbing. And so what we want is we want for that to not climb. Now there's sort of two possibilities of what could be happening here. Either we could theoretically have a leaky capacitor, but that capacitor, the other leg, is on ground. And so if it's leaky, it should be going down instead of up. The other possibility, the likely possibility, is that this op-amp is leaking some current back into this capacitor. Or it could be that the keyboard itself is somehow leaking current through R61 and R63. So if we actually, the glide is all the way up, we should be able to measure the voltage across the slider R63. And so get one side and the other side, and we are at basically, what are we at? 0.003 millivolts. We short this together. Yeah, that's 0 basically. So we have just a small offset in our polythermal offset in our test leads. So there's no current going through R63, and that means that we're not getting current from the keyboard, which only leaves the op-amp. So luckily, we have a replacement. So this is a 353 op-amp, which is, I believe, a CMOS input. The important part is that it's supposed to be a very low bias current. And so this, positive input here should be like it's a not connected input. But clearly it is not connected. So to replace it, I have got the TL032 AIP. And the A means that it's one of the nicer binned ones, which was like 2 cents more expensive. The I means that it has a wider temperature range, I think. And the P means that it's in a PDIP package, which is what we want. So there is our new chip there, and we will go ahead and pop the old one out. That is U7, which I think is way over there. And then pop this one in. All right, so here we can see U7 over here, and my desoldering iron should be almost heated up, maybe? No, I forgot to turn it on. Okay, that'll take another second, so I'll flux up these pins, and then we will swap the chip. Oh, I love this desoldering gun. There we go. The old one out. I'll make sure to line this up the correct way. There we go. Nudge the pins into place. So that looks good, and we should be able to put this back together and make sure it works. All right, 2 screws should be enough to test this. So let us plug back in and test. So we're plugged in and powered on. What does it look like when we look at our voltages? So stick one there and one there. And we are just bouncing around doing nothing, looks like. That's pretty cool. So let's see. We'll play a key. Okay, so 200 millivolts. Let's do this key. We are at 654 millivolts. High C. We should be at 1.4. So that's, yeah, it's not moving around anymore. Anything is going down a little bit. So I think we solved that problem. Although I suspect that we might need to adjust the voltage that's coming out of this, because those numbers did not seem quite correct compared to what I thought they should be. Let me double check. All right, so if we look at the keyboard schematic here, we have our current source and our 100 ohm resistor array for all of these. How many keys is it? 32 keys, I think? Maybe? 1, 2, 3, whatever. Anyways, we should have 2.58 volts at the top key, which is the C5 here. And we should have 0 volts at the F2 key here. So if we go right here and go down to the bottom of F2, we will see we are at minus 5 millivolts, which is not quite correct, but it's kind of close actually. And then at this side, you see we are at 2.58. That's actually not too bad. Yeah, so we're looking at 2.58. That should have been 0, which I guess to 2 decimal places it was 0. You know what? I had the keyboard glide turned all the way up, so that is probably why we weren't getting full volt. Let me turn that back down. So now if I hit F and I check the voltage, there we are. That is 0.5 millivolts, which is fine. Hit C. Now we should have 2.579, 2.58. Okay, so our keyboard tracking is now working basically perfectly. That's good news. Now the next step here is to get Oscillator 1 aligned. Oscillator 2 wasn't too bad, although we'll align it as well. The keyboard seems to be well aligned, so that's good. So I need to grab my screwdriver and I need to actually look up the alignment process. But yeah, I'm going to get more screws back in here because we can access everything from the bottom side and from the back. And then I'm going to grab my tiny screwdriver and I'm going to warm up my oscilloscope and I'm going to read the documentation. Be right back. All right, we are set up to do our alignment now. And if we look at the scope right now, we can see we're at the A4. That is on R12 right in here, which you probably can't really see very well. But look at our 12, that is a 440, and we can see that we are at 441 hertz, and we can validate that with my tuner here. If we hit A, you can see we are at A. Unfortunately, on the lid, on the front panel, our poly tuning is like way to the side. So it's like pointed that way. We want it centered when it's tuned. So I'm going to align that right to the center. And now we can see that we are at an A sharp almost. So we're like almost a semitone off. So I'm going to watch the scope and change the poly frequency until we are at 440. Ooh, that is touchy. Oh, 440. Nope, 445, 431, 439, 447. That is bouncing around all of a sudden. Hang on, this wiper is probably dirty. That's a little more stable. All right, so nope, too high. 440 exactly. Now, that will probably drift as it warms up and cools down, but I don't care. We have the tuning knob at the top. And, you know, if we touch this one, it'll probably be off by quite a bit again. Anyways, we are much more centered now on the poly tuning. That's step one. Now I'm going to figure out what step two is. All right, so for the keyboard current source, we're just going to do a quick check on this because the low was a bit high. It's currently reading at 6 millivolts. So it says set the keyboard size to minimum, measure at U7 with your DVM, which is over there. I'm just going to measure it straight off the keyboard because that's just fine. All right, so we are looking at 6.6 millivolts. So if we grab our screwdriver and go in here, we should get that down to 0. Very close to it, maybe not exactly. You know what? I'm going to call that good. 0.212 is fine. And we'll double check the other side. That's 2.579, and you know what? I'm not going to touch that because that's supposed to be 2.58, and that is close enough for me. So we got the keyboard current source, polyphonic tuning. Now, tone source 1, scale, frequency, and high frequency adjustment. This is the one that's going to be exciting. I have to locate frequency trim at R1001, our scale trim at R1008, and tone source at R1009. So it wants me to monitor the audio output of C2011. Where's that one? So C11, the output is the plus side. So that's the plus side. Good. So we have to put the tone source mixer for number 1 up, open up the filter. Let me see, square wave should be good, octave 0. And if we hit A, we are too low level to get the signal tracking. Let me adjust that. That is 230 hertz, which means we are at the wrong A. This A. We're at 350 hertz. So that is obviously low. Double check, make sure our tuning is set right in the middle. We are. So yeah, 348, which is not good. So, tone source 1, freak trim R1. Is that the one in the back? Oh, it's not. Oh, it's the one in the back. Great. So we're at A. Oh, wrong way. Too far. Too much. 430. 440. That's a positive sign. And then, what does it say to do next? Oh wait, it wanted us to start with a low A. What's that? Low A is 200 hertz, not good. Actually, which octave are we supposed to be on? Oh no, wait, change tone source 1 octave to 0, press low A, and that should be 220. So low A is 199. So that's actually not that far off. Okay. So if I switch this down to there. All right. So it thinks that is at 67. Too high. We want this to be 55. So we have just tuned using the frequency trim our low A to 55 Hertz. Now the next thing to do is play a high A and see if we can get it to 220 using the scale trim, which is the next one over. So high A, we are looking at 175. So we want this one. So we're at high A, we're at 175. Nope, wrong way. We want 220. Ooh. We just ran out of adjustment. That's not good. Okay, so I had a little bit of a concern that this is going to happen. Basically, my assumption going into here was that someone got out their screwdrivers and started poking at these pots trying to fix this without understanding what was broken. I'm now leaning towards the thought that instead what happened is that this op amp, which is the primary oscillator for tone source 1, might have gone bad. So that is a 353, and I think I will purchase a new, probably not a 353. I'll probably replace that with something a little more modern, probably, what was it, a TLE 2072, and I will replace both of them at once. So there's like U5 A and B here, and U5 or U2 A and B here. So we're going to replace that. I need to order some parts, and then we will pick this up later. And hopefully then we will have the full range of our tuning source. Piper came in the mail. Exclusive. It arrived. It arrived. All right, so I went ahead and got a 2 replacement op amps actually. So we got a TLE 2072 to replace this 353, which might actually be a TL 072 originally. I think they said on the side here. Yeah, in fact, they did. Said on the side here that the 353 is also substituted by a TL 072. So that's probably actually what's in here. Anyway, I am looking to replace this one, and I'm also going to replace this one. This is just 2 halves of the same chip. Both of these are. Now, I didn't explain before why I think these op amps are at fault. I mean, obviously we have the fact that we've had to change like 2 other op amps in this synth already. So, you know, let's bet on a third, obviously. But the thing is that what we are seeing is that we were running out of adjustment on our scale adjustment here. And so we were trying to change this node by, we're trying to change that by whatever, 18 millivolts per octave, 17.9, I guess it says. And we were not getting a doubling of the frequency, which would be a doubling of a current going through this transistor here. And so the chances of this transistor pair being like so bad that it's no longer tracking, I'm hoping those are pretty small. I mean, I guess it's possible. But like the only other thing that could be to blame here, because I mean, remember, we're looking at this node here that is connected to an op amp, a capacitor, a transistor, and a transistor. How can I explain this? So, we have our, don't slide away. Okay. We have our Ebers-Moll model here, right? Our collector current is, roughly speaking, our saturation current times e to the VBE over VT. So this doubles every 18 millivolts the current. And how do we screw this up so it doesn't double? Well, anything before this, this adjustment, that's not really going to change significantly how much extra voltage we put in here double it. I mean, obviously the scale is going to change it a little bit, but it shouldn't be so far out. Because, you know, this is not, you know, dependent on any sort of specifics of the transistor in terms of its doubling. Its actual output is, because you have saturation current there. But, you know, let's just say we add, you know, a plus epsilon to this. Well, now we no longer have a doubling because we have some sort of fixed leakage here of current into or out of this node. And, you know, chances are it's going to be a leaky op amp, like maybe that transistor, I don't know. I have some of those in a drawer, I'm pretty sure. So if it turns out to be that, we can still deal with it. Anyway, that's sort of my thought process there. And that is probably really hard to follow because I'm sort of rambling off the cuff. But short story is, I got a replacement for this op amp pair and for this op amp pair because, you know, chances are if this one's going, this one's going. So let's just replace it and see how that works. So I'll be right back after I disassemble this synth again. All right, so we are looking for U2 and U5. So U2 is here, U5 is under this bundle of wires here, which should make it slightly interesting. So that is going to be U2 right there. So that one was U5, and I think it's probably dead. Wait, no, that was U2, right? U2 I think it's probably dead. U5 is the one, I think it's still good, but we're going to replace it anyways. So I'm going to set that one upside down so I remember which was which, just in case I want to reuse that one in some other less critical area. So this one's going to go into here. Making sure we get the pins the right way round. And then we will poke them into the holes because they are slightly splayed. There we go. And we got that the right way around. We did. Pop in U5, which is the other way around. There we go. And yes, I know I can roll these chips to make the pins straight, but I kind of like having them slightly splayed because then they stick in the holes and don't fall out. And yep, that all looks pretty good. So now we should be able to reinstall this and resume our alignment, I think. All right, we are set back up for doing our alignment. Grab my screwdriver. All right, frequency, scale, scale, frequency. So frequency 1 should be this one. Now, I'm currently looking at, what are we at? Low A, we are at 56 Hertz, and we want that to be 55. If I can ever get this damn screwdriver. Got the screwdriver in. So 55, we want, oop, that's too high. So, oop, 54, 55.36, 34, 27, 24, 55.1, 55.0. And now, if we go to the next one over, and we hit the high A, we are at 181. So we want, what is it? We wanted 220 on this one. Ah, son of a bitch. You're at 159 to 181. Uh-oh, we did not replace the right component, I guess. So I blamed the op amps and I was wrong. Oh no. Well, the next candidate is the PNP transistor. So let's have a look at that. All right, so when we are resetting our triangle wave, we are using this transistor here, Q6. That's a 2N3906. So I think I have a bucket of transistors around here somewhere. Let's see if I can find the right one. Ah, here we go, 2N3906. So this is straight out of the bowels of China, which I'm sure are totally not really shitty second-rate transistors, but I guess we will find out in a moment. So let's put this in, I guess. All right, so the transistor we're looking to replace here is Q6. I believe it is Q6, and is right next to the capacitor that this op amp is oscillating, and also right next to the high frequency offset control thingy, which I was supposed to start with centered, but it didn't really have a lot of effect, so we'll just center it, and then we'll pull out this transistor and replace it. That sounds like it just fell right out, so I would say it's pretty loose. So make sure you get it the right way around. All right, let's get this soldered into place. My soldering iron is slightly too cold, but it's fine. We made it. All right, clip the leads, get this back together again, and we should be good. All right, well, I had to put my thinking cap on for a little bit and work through what the hell was going on. So I checked basically everything in this circuit. I checked the inputs and outputs of this comparator. I checked and compared against the inputs and outputs of this comparator. Because remember, all of this was working perfectly. It was, you know, getting our doubling of frequency every time we went up an octave, but this one wasn't. So I checked the comparator, I checked the inputs of the transistor. It's like it's identical between the two of these. I was looking at absolutely everything to see if like maybe this comparator was leaky or whatever. Like the waveforms, like right here were identical. Finally, I'm like, you know what? These CA3046 transistor arrays are socketed because they have the Tempco resistor mounted underneath them. And I said to myself, I says, all right, now these are using the same pair on each of them. I'm just going to swap them and see what happens. And I know you're saying to yourself, oh, I know what's going to happen next, but actually you don't know what's going to happen next, because instead of the problem moving from here to here, the problem just went away. And so notice I said these are socketed. I think what probably was happening was that like pin 1 here had a bad connection or something. But anyways, let me demonstrate where we're at right now. So granted, these are both out of tune, so take the actual solid values with a grain of salt here. But if I put a probe on there, actually let me scale that back a bit so you can actually see the waveform. All right, now bear in mind that these are both going to be probably out of tune. So let's have a look at this one first, and we'll hit the low A, and that is 110, which is actually in tune, mysteriously. I didn't do that on purpose. Next A up is 220. The next A up is 440. So that is spectacularly in tune, completely accidentally. Cool. Look at the other one here. So we are at 258, 260. So 26 divided by 2 should be 13. So 12.8, 128, yeah, basically 129. So that's good. And then the low A, 64.5. So we are in business. So yeah, that was like about an hour wasted poking at this thing with a scope and a voltmeter and everything. So cool. But it does mean that we can get back on with the alignment, except I just wasted an hour on this and I have a headache. So I am going to put the screws back into this and then go sit on the couch for a while and continue this tomorrow or something. But for you, it'll be in a short second. All right, we are back and we are going to tune this synthesizer, finally. I had a wonderful night's sleep, nice bike ride in the morning, a productive day at work, and a little nap on the couch, and so I am refreshed and ready to go. So, back to tone source 1 trim. So we are hooked up to the headphone outs because I don't want to put my scope probe in here because I'm about to close the lid. And I don't want to squish my scope probe. At least, not as much. So, if we hit the low A, we are looking at 65 hertz, which is too high. And so, that is going to be this first one here. Yep, wrong way. 55.5, a little less. 55.1, 4.97, close enough. We're gonna have to do this back and forth a few times, so. All right, we are at 220.5. Okay, we're actually not gonna have to do this a bunch of times. So let me get this spot on as I can. Actually, 4.9, that was what? Half a hertz fast, so we are going to be persnickety and see if we can adjust that away to 0. All right, 220.1 roughly. That's probably good enough. And here we are at 54.95 still, so that's pretty good. Let me get the screwdriver in here, possibly. 55.0, close enough. 220.6. All right, bring that down just a slight bit. You know, the hardest thing is getting the slotted screwdriver in the actual slot. Oh, there we go. All right. Wrong key. There we are. 220.7. I'm going to call that close enough. All right. So now we want to flip up the tone source octave and go to the high A. And we are at 890. So now we have to lift the lid. We need to poke at high frequency 1, which will be that one. Not that you can see that one because it's under here, but look at the manual and I'll show you which one to do. So 880, 876, a little too far. 9, 881. 880. All right, that's 880 basically. Then close the lid. Go back to this octave and all right, we're at 54.5, so we go adjust this again. And we do this back and forth, and I am probably going to fast forward to the end because we're just repeating what we've already done, which is mostly trying to find the slot in these stupid potentiometers. So 881, 880. Yeah, it seems fine. And down a little lower, we're still at 220. And if we switch the octave, we are at 55. So I'm going to call that good. All right, let me check what I need to adjust next. So this says square wave adjustment. So I actually have my beauty on my scope at the bottom there. So it says turn on the square wave. Where does it want me? I press any note and adjust the square wave trim until it has 50% duty cycle. So square wave trim is actually, I think, right next to it. Yes, because we were adjusting high frequency and the square wave trim is right next to it. So let's just do the A in the middle and we have 48%, it looks like. %, 48, 49, and 50.2. Because you know the audience is going to be able to hear the difference. 49.95 is good enough for me. Now, do the same thing for tone source to scale frequency and high end. All right, I'm going to not record that because it is exactly the same as number 1 except with different pots. So we will come back to the next step, which is filter scale after I'm done this. All right, both oscillators are tuned up and now we are doing the filter. So modulation to 0, glide to 0, mixer controls to 0, cutoff frequency is electrical 0, so that is probing this pin right here. This pin right here, which I got to 2 millivolts is close enough. So you set the slider to get that. Emphasis to maximum, contour cutoff to minimum, keyboard tracking is out. Contour tone sources to continuous. Do I have that set? Contour tone sources continuous. There we go. All right, contour cutoff was 0. That's that one. Master volume to maximum. Center the blah, blah, blah. I'm not going to center them because we're going to adjust them. So verify the filter is oscillating. It is absolutely oscillating at 804 hertz. So we want that to be at 660 hertz. Interesting. Filter cutoff trim. Filter cutoff trim is going to be this one, which is right here. So we'll get that to 660. Oop, that was too far. And this is like plus or minus 50 hertz or something, so 662 is just fine. And then we need emphasis trim until oscillation at pin 6 of U1012 is minus 23 dBm, 55 millivolts RMS, 155 millivolts peak to peak. So U12 is over here, and that's going to be behind that bundle of cables, and the pin 1 is going to be down, so we're going to be 1, 2, 3, 4, 6 is going to be right there. Pin 6. 250 millivolts, that is too high, because we wanted 155 millivolts. Okay. So let's see if I can hold this here. Grab my screwdriver, and that is changing the frequency. What is going on here? What am I adjusting? Oh, that's filter scale. Damn it. Wrong thing. Okay, 660. Now I'm going to adjust the correct one, which is the emphasis trim pot, which is right behind my hand. Lovely. Switch hands here. Okay, we have 250 millivolts. Too much, so we need that to go down. Oh yeah, that was jacked up all the way. That was 150 millivolts? 155. Close enough. All right. So, change keyboard tracking, switch to full. Keyboard tracking on to full. Press and hold low A. Low A. And I'm measuring at the same pin, I'm guessing. All right, and that is 869. That seems too high. Okay, we are back in business. I had misread the instructions slightly, and also was sort of chasing my own tail a little bit, because the 3 adjustments here are all interrelated, and it seemed like only 2 of them should have been, but 3 of them were. Anyway, procedure, you adjust the cutoff trim. First of all, center all these up. Follow that instruction there. Adjust this with the keyboard tracking out so you get 660 hertz. Do that. Get your 55 millivolts RMS on, what is it, pin 6 of U12. Did that. Switch the keyboard tracking to full. Do the low A, and I got that at 440 hertz, pretty much exactly. So we're cool. And we adjust the cutoff to get that to 440. Basically, you go through setting the scale trim and the cutoff trim with like high A and low A until you get it to like 1760, which I'm actually like 1763 for 1. It's wobbling around a little bit. And yeah, you want to get this to like your good 2-octave spread here. So like 440 to 1760. I got screwed up here because when I was doing this adjustment, the emphasis trim was not in the right place, and so that changes the frequency response of the rest of this circuit in ways I don't quite understand. Needless to say, I had to go back, adjust the emphasis trim as well, and then do the scale trim a couple of times over and over, but now it is tracking properly and we're good. So, VCA balance adjustment. I have to do a bunch of stuff here, so let me get this out of the way and adjust things here. So, we want modulation filter minimum, modulation rate to be maximum, modulation auto contour trigger in, contour tone sources to be keyed, filter cutoff frequency to maximum, peak emphasis to minimum, master volume to maximum, all mixer controls to minimum, monitor pin 6 of U1011 with AC voltmeter, okay. And adjust VCA balance trim 1094 for minimum output level. So I have my voltmeter and I'm going to set that to AC volts. And now let me hook up to ground over here. And it wanted U11. So U11 is going to be the one closer to the back panel, and we wanted pin 6. So it is going to be 1, 2, 3, 4, 5, 6. Let's see if I can successfully find pin 6. Should be that one. So we're at 12 millivolts. That sounds pretty low, so I'm probably not going to need to adjust this a lot. All right, we are under 1 millivolt. That is good enough for me. Are there any other adjustments we need to make? That is the end of page 18. So we are done. Hooray! So I should hook this up to a speaker and see what it sounds like now, after I put all the screws back in. Let me do that. All right, I think that sounds pretty creepy. I kind of like it. The mix of the polyphony tones and the actual VCOs is actually pretty cool. You get, you know, a mono synth, but with chords. I like it. It's pretty cool. So I hope you enjoy the video, and I will see you on the next one.